pressure. Pressure. So we deal with those components for this example one at a time. So I have now friction is 0, why? Why is it 0? Well, we said we want to assume it's frictionless, so it's gone. What else can I neglect in this forces on the left? Huh? Body, yeah, because we say we can neglect gravity. Now, what I left with then is the pressure force. So let me take the control volume and draw it all myself, right? Where I can visualize that I have flow coming in and flow going out. I should specify but despite that velocity, that I have this imaginary rectangular box, what will be the pressure acting all around this control wall? The magnitude and the direction. It's always normal, right? Normal, but is it pointing into the control volume, or is it pointing away from the control volume? This is a very subtle question. I'll give you the answer not to confuse you. First, you were told that pressure is everywhere, including the jet, PA. And pressure always act normal and inward. So let me put this down as a very important reminder. Because later on you're going to forget this. As such, for this problem, I have PA everywhere on the left-hand side. I have PA everywhere on the right-hand side, including the jet, as well as top and bottom, all normal and inward. And the important clarification is completely independent of that jet velocity. Totally unrelated. Think of this as a block of wood or a tank that is submerged in water. Where will the pressure act on the surface of this tank? It's always normal and inward. It's not a very good analogy, but it will help to capture the direction of this pressure. So to help you visualize the fact that the pressure is totally independent of velocity, if you put this ball underwater, the pressure has to act normal and towards the surface. Yes?
What if your closed volume pressure is less than the surroundings?
Then you have to account for that. For example, if you're told otherwise that the jet is not at ambient pressure, which you will do for many of your homework, then when the jet come in, you have to tell me what that pressure is. And that has to be accounted for differently. But let's don't deal with that now. Let's keep it simple. So that will be a problem that will change the answer. But you're told not that case, at least for now. Fair question. Do you understand this very important point that will come back and haunt you later? All good? Okay, so if that's the case, the net contribution to this PA all cancels out. No pressure to speak of because they're all equal everywhere. So I take care of the pressure, happen to be also 0. The only thing left is summation of all the forces in the x direction. The only thing left is that anchoring force. And here it's very important that you pay attention to the sign. When I draw on that diagram the force from my intuition as an engineer, I know I have to push to the left to anchor this plate. And relative to my xy coordinate, what is the sign for that F? Negative. Negative. That's one place that you can easily miss, not being able to deal with the sign. So when all said and done, the only force left, despite the three constituents, or three components, the only thing left is this anchoring force in the opposite direction of positive x. Okay? I have 3 minutes to wrap this up, and that's all I need. Now let's look at the right-hand side, which is the momentum, I call it flux. I'll elaborate on that later. There's a special term given m dot u. So you can do this in 2 minutes, trust me. M dot u in and out with the sign as such. So let's deal with the exit. Let's do the inlet first. Forget the minus sign. Okay, so I'm going to leave this to come back with later. M dot u1. What's this small u1 in the diagram that you have given to the far right? It's the same as the given nomenclature capital U1, right? So I have related the small u to the problem nomenclature. Here is the interesting part. Our exit at station 2, which is a wing, m dot 2. What is the velocity component at the exit of this jet? Circular, top and bottom. That is parallel to the x-axis. Zero. Zero. This guy is zero, because the plate deflected the jet by 90 degrees. Do you get it? So 1 minute. Putting everything together, summation F is now negative F. The only thing left on the right-hand side is negative m dot 1 u1. 2 negative give me a positive, and my assumed direction for the force F is correct. It's pointing to the left, and it ended up to be positive. So I win. I was correct. 1 minute, and you're in the test. You panic. The answer has to be in terms of rho, v, and diameter. You have m dot 1 here that you haven't get rid of, and we're out of time. What would you do? What equation I haven't used? This is a real-life example that you will encounter in your test. What have I not used yet? What is rho v a? You haven't used continuity, and that's how you pose the problem. So the answer then becomes, and we'll touch on this next time, in a week. And that's what it all boils down to. Use of momentum and continuity. Okay, I did it a little quick. We'll come back and revisit it, but work on all the homework. I'll see you in a week.